I wanted to wrap up this week's activities with a final lecture on forest management and some additional environmental effects that we may have touched on already, but I just wanted to give some more details. So just to review what you should have learned this week already, you should have learned some details about environmental problems, not with forestry, but environmental problems that affect forestry and that are caused by forestry practices. You learned about some sustainable forestry methods, including some that are being done right here in Northwest Pennsylvania. And you learned about urban forestry as part of the solution to forestry problems. So I first wanted to look at some more at forest management and different techniques that can be used. First of all, you need to recognize, and I'm sure you've already seen this, that there is a trade-off between the demand for products from forests, including wood products and paper products that come from wood, as well as some additional products that wood can be used for, including things that are processed and added to other products. So there's a trade-off between product demand and ecosystems and keeping those forest ecosystems healthy so that those forests can continue to grow. So that's really what all foresters have to contend with, and they're all very aware of that. And different locations and different companies are going to manage forests differently. So as far as forest ecosystems go, and I know you've already been introduced to this, and you read about this as well. In fact, this is the figure from your textbook. Forest ecosystems are very complex. Especially when you think about tropical rainforests as being forest ecosystems. They're probably the most complex and most diverse ecosystems on Earth. And yet they are still being harvested for products and also depleted in order to clear land for agriculture. So we need to, first of all, understand ecosystems, know that they're complex, know that there's a limit to what we already know. And you saw this complexity way back at the beginning of the semester when you watched The Magical Forest and saw all of the connections between the organisms there. And think about that and how astounding that was, but also how little we still know about the functions of ecosystems. So I just wanted to kind of bring this to the forefront, and even though you've already read about it, you've already talked about it, I want it to be very clear that forest ecosystems are really complex, and when we go in and chop down trees, we're affecting those ecosystems in really big ways. Okay, so we're going to take a look at 3 management methods that people use all over the world. So the first management method is maximum sustainable yield. So with each of these, I'm going to look at the theory, the practice, the benefit, and the detriment to that method. So the theory for the maximum sustainable yield method is that, and this curve should look familiar, if you look back at material from population ecology, this is the growth curve for populations if there's a carrying capacity. So if we take a look at this curve, there's slow growth to begin with, and then the fastest growth occurs right here. In fact, if we were to just take a snapshot of this growth, it really is exponential. And so the theory is that the population is growing at its maximum speed when it's at intermediate population size. Now in forests, as far as trees go, their maximum population size actually maximum population growth actually occurs when those trees are at intermediate age. And so the practice of maximum sustainable yield is to harvest trees at intermediate age. And that this, as long as you have estimated the tree population correctly, this will maximize timber harvest over time because the forest will continue to grow at this rapid rate if you maintain it at that intermediate level. So that's the practice. The benefit is that you get maximum extraction without depletion of the resource, which is great for products, or great for production, but also great for sustaining that resource. The detriment to this is there are a lot of other organisms that rely on mature trees. But if you're harvesting all of the trees at intermediate age, the forest never develops mature trees. And so you're going to limit the number of organisms that can actually live in this forest. So you're not really maintaining the ecosystem functioning of that forest. So management method 2 is kind of at the opposite end of the spectrum with ecosystem-based management. The theory here, which is also basically the same as the benefit, is that your goal is to minimize the impacts on ecosystems so that the ecosystem remains intact and functioning at its highest level while still harvesting the products. So especially I'm a biologist, I would absolutely want this to be the case in all forest management. However, we need to recognize that the practice of this ecosystem-based management is really difficult to do. As I've already mentioned, forests are very complex, and so you'd have to be continuously studying them before and after and during harvesting, and that takes a lot of time. I mean, think about life cycles of all of these animals. Insects are pretty quick, but trees themselves can live hundreds of years. Organisms like jaguars, larger organisms, can live a couple of decades. Alligators can live even longer than that. So just to use those as examples, in order to study ecosystems over time is going to take decades. Meanwhile, you need to be harvesting and measuring your effects. So this is really difficult and time consuming. Not to say that it's impossible, but it's not going to be your best management strategy if you need to be providing products and a lot of products at a quick pace. So the detriment here is that the profit may be reduced. Again, if this is done correctly, maybe it wouldn't be reduced, but there is the possibility, especially when you take into effect the cost of continuous monitoring as well. So this is a difficult one. It's not impossible, but it's not going to be your management for mass production of forest products. So the third management method is kind of an intermediate between the two. And this is actually the method used by the National Park Service and National Forest Service in the United States, and that's called adaptive management. So the theory here is that you use a variety of methods and adapt those methods over time to the needs of consumers as well as the needs of the ecosystem. So in practice, what you need to do is try a variety of methods, test their effects, and measure the results of those methods, and take a look at all stakeholders. So everyone who has a say and everyone who is impacted by those management practices. So the benefit here is that you get continuous improvement of methods and also continuous knowledge of the ecosystem and your effect on it. The detriment is that it requires patience and knowledge of forest ecosystems. So you can't just go in and chop everything down without even thinking about things. So it does require knowledge. And in fact, you can get forestry degrees. Anybody who is a forester probably has at least a 4-year degree in forest management so that they understand forest ecosystems. This can also be more energy intensive, again, because of the work required to monitor and measure results. And then because of the amount of work that goes into this, this could also be more expensive. Okay, so there are a few other management decisions that need to go into forestry. One is whether or not to use plantation forestry. So the term wasn't used, but you were first introduced to this when we learned about palm oil plantations or oil palm plantations. Plantation forestry really is applying the concepts of agriculture to forestry. So in this case, trees are grown in a monoculture. So if you look on the right, this is a monoculture of oil palms, and on the bottom right is a monoculture of what I think are beech trees. So trees are grown in a monoculture. The best species, tree species for plantation forestry would be fast-growing species. And what you end up with are even-aged stands of trees. I don't want to call these forests because even though they are trees, many trees growing in one area, they are all even aged. They're not very complex. Notice you don't have a lot of understory. So this really isn't a forest as far as, it's not a forest ecosystem. In fact, this type of forestry does not provide good habitat for other organisms at all because of that lack of complexity. Also, when you have even-aged stands of trees that are all the same, they tend to be prone to disease, either native diseases or invasive species, and then you could really get your whole stand totally wiped out. Now, trees are not as easy to manage for pests as other plants because of the nature, the woody nature. You can't just spray an entire forest with pesticides, even when it is on plantation forestry. It just doesn't work as well. Now, so it seems like plantation forestry would be a bad idea. However, if we have a set plot of land and we have a set product that we need, perhaps using plantation forestry would be a good idea in order to limit the effects on the surrounding forest. So if you're going to use a smaller plot of land to grow specific products that you need, and it keeps you from expanding into the surrounding forest that is an actual functioning forest ecosystem, then plantation forestry may be a good idea and part of the solution to some of the environmental problems caused by forestry. Another management decision that needs to be made is how are you going to harvest those plants? Now, for most of human history, clear cutting is what we've done. And this shows on the top right shows a clear-cut forest. Basically, you go in and you cut everything down. You'll take what works for you, and the other stuff either gets lost or left or shredded. Now, obviously, this completely destroys a forest ecosystem. And this can happen. If you Google images of clear cutting, this can happen for miles and miles and miles. And obviously, this is just horrendous to the ecosystem. There is still clear cutting that happens now, but because humans actually, there's almost a visceral response to seeing a forest completely destroyed like this. So citizens are really anti-clear cutting. Because of that, it's really forced managers, foresters and lumber companies to use better practices than clear cutting. So one of the potential alternatives is to leave a few trees, and this is called a seed tree system. So notice here there are a few trees left. Basically, those are going to provide seeds to repopulate that area. Now, again, you're still destroying the forest ecosystem. You've completely just wiped out the complexity. So this is still not ideal from an ecosystem standpoint, but is certainly better than clear cutting. And more we're starting to see selection systems like what you saw described with the Foundation for Sustainable Forestry, where they go in and they choose specific trees to take out. Now that's much more time consuming and you don't get as much wood all at once, but it is a more sustainable practice. So you're going in and you're choosing specific trees to harvest, but largely leaving that forest ecosystem intact. The last thing that I want to mention is the effect of climate change on forests around the world and our ability to sustainably harvest forests. With climate change, we know that temperatures all over the globe are rising. Some places, especially places that are already dry, are seeing even drier conditions due to climate change, and that is predicted to continue. And so with drier conditions, among other factors, we are seeing an increase in wildfires. Finally, with warmer temperatures, it's affecting a lot. It's actually helping insect pests and other pests to trees. Those insects are able to live at higher elevations. They're able to live over winter when normally they would have died out. And it also creates a good ground for invasive species to take hold. So what we're seeing is a lot of forests that are being affected more by insect pests and invasive species.